AB Calculus, Section 5.1, Area Approximation. We are to sketch the given function and find the area under the graph, but above the x-axis using the stated domain. So first thing we have is f of x is equal to 4. It's a horizontal line at a height of 4. And we are looking on the domain between 0 and 5. 0 to 5, that's going to stop us right here at 5. So the area we are interested in finding underneath that function, but above the x-axis for x between 0 and 5. This is the area that we want, this rectangle. So we will see that area is base times height, or 5 times 4, 20 units squared. When we look at this next one, f of x is 2x on 0 to 3. That's a line going through the origin with a slope of 2. And looking at this from x is 0 to x is 3. Beneath that function, but above the x-axis, this is the area that we're looking for. And we have a right triangle. So area is 1/2 base times height. 1/2, 3, there's the base, times the height. Well, that height can be determined by plugging this 3 into that function. So this point up here is at 3, 6. Height is 6, so we'll have 9 units squared for this area. The next graph is a piecewise defined function. And our graph will have y equals x for x between 0 and 2. There's y equals x. And this point right up here is at the point 2, 2. And we have a horizontal line at 2 for a distance for x between 2 and 3. So this stopping point there is 2, 3. And this linear piece, 8 minus 2x, we know we have a slope of -2. It starts right at 3. So I'm going to plug a 3 in here. 8 minus 6 is 2. So when x is 3, that y value is 2. That makes these guys connect. And when x is 4, this function piece is back down to 0. So we're looking at this. And we have a trapezoid. Again, you can divide this up into rectangles and triangles, or you can remember the formula for area of a trapezoid. 1/2 height times the sum of the bases. Height is 2. Top base is 1. Bottom base 4. And that area is 5 units squared. Looking at number 10, f of x is the absolute value of x minus 2 plus a 1. We know the shape of an absolute value graph is a V, and this V has been shifted 2 units to the right and 1 up. So 2 units to the right, 1 up. There's our absolute value starting, and then we know both sides have a slope of 1 and -1, or 1 or -1 actually. So we have a graph that looks like this. And on the domain specified between 0 and 4, here's 0, 4, this is the area. And again, you can divide this up. You could put a rectangle down here in the bottom, find the area of this rectangle, plus the area of that triangle, plus the area of that triangle. Or another option, and some of you may like this one better, is to put a horizontal here, find the area of that whole rectangle, and then subtract off the area of that triangle. Either way, you will come up with 8 units squared. You try, make sure you can come up with an 8, whichever method you prefer. This one down here, f of x is the square root of 4 minus x squared. We run into a bit of trouble trying to graph that. First, however, if we come over to the side and think of this as y equals the square root of 4 minus x squared, and square both sides, add that x squared over to the other side, and we see we have a circle centered at 0, 0, radius 2. Well, we're only supposed to look at between 0 and 2, so we are going to only graph the right-hand side of this circle. But a circle is not a function because it will not pass the vertical line test. So we have to look back at this and realize that square root of 4 minus x squared can never be negative, which means that y will never be negative. So we will not graph the bottom portion of this circle. We only graph the top portion of that circle, radius 2. And this is the area that we are looking for. And that is a quarter of a circle. So that area is 1/4 pi times radius squared with a radius of 2. And we get an area of pi units squared. This last one here, f of x equals x squared. On this window from 0 to 1. That's pretty tiny, just this little bit down here. Alright, it's pretty hard to tell in here, but it almost looks like we could put a horizontal here and see a quarter of a circle with a radius of 1. They're pretty darn close, but actually they're not the same thing. The curvature here on the parabola is not the same as the curvature on a circle. A circle is much more curved than this curved portion of this parabola. We can only find an estimate here, and that estimate for that area is approximately 1 for that square minus the area of that quarter circle, pi over 4. Again, we can't get that exact value because the curvature here on this parabola is not the same as the curvature on a circle. Please tune into page 3. Don't just quit right here.